Good afternoon, everyone. My name is Stéphane Zermatten, and I'm going to give you a presentation on Google Data APIs. The subject of the presentation will be Google Data APIs in general, and also how to survive posting or querying data on these APIs. So first, as an introduction, here's a code that was written by Jeremy Sawadney from Yahoo just after the launch of Google Base. This is a really interesting code because he totally gets it. What he says is the benefit of GData is that you'd have a single API that could be used to query, update, and index structured data on the web, anywhere on the web. It's a pretty powerful vision and something I didn't expect to see for a couple more years. So this is really the mission of GData. Making data available, making it possible to update and delete and search all data in a way that is more appropriate, that is as appropriate as possible for the nature of the data you're working on. Here it's talking about structured data in general because it was about base, but it can be applied to absolutely everything. And it is being applied to absolutely everything. Google has several APIs. Some APIs are specialized, most APIs specialized. Ajax API is mostly specialized on presentation. Desktop API is specialized for desktop operations. Google Data APIs are a family of APIs that are not really specialized. Their real goal is to make everything available through an API using XML that is available on the website. If you can do something on the website, you should be able to do something in an API. You should be able to write an application that does the exact same thing, and usually more. This is what is meant by full fidelity APIs. And Blogger and Google Base are two early examples of these APIs. There are many more, and I'm going to list them afterwards. So the first question when GData was written, was really, how do we write web service? What kind of protocol is interesting for us to write web services in? And the first answer was SOAP. We tried several APIs and wrote several APIs using SOAP. SOAP is nice in a way because you can have arbitrary actions, you can have arbitrary data, and you get a very well-defined, complex service description and behavior in WSDL. But it was really a bit too complicated for most users, especially programmers. So REST came up. REST is another kind of APIs. It's a simplification in that you have only 4 verbs, 4 methods that you can apply on everything. This is CRUD. Create, request, update, and delete. That's all there is. And you operate on XML documents, usually. And each document is identified by a unique URI, which is usually, for convenience sake, a URL that you can query. So we chose REST over SOAP, as I said, because it's simpler, it's more programmer-friendly in that you can just type in the URL and you got the data you wanted in your browser. It's sessionless, which makes it easier to cache in a proxy, using technologies that are very well understood and very well supported already. And that also makes it scalable. Now, GData is built on the Atom publishing protocol, which is itself built on Atom. Atom is a very simple format for that you will use in RSS feed readers. You will see in a feed reader a title, a description, a link, and updated published dates. And that's about it. But that's a lot already. And to that, the Atom publishing protocol added 4 HTTP verbs. Get was already available. It added update in the form of put. It added insertion as form of post and deletion in the form of delete. Now to this, Google added several extensions because that wasn't quite enough for us, for everything we wanted to do. The first extension is the data model. That is, what is in an entry? A title, the content, link is not enough to, for example, represent a calendar entry. So we added some more stuff to it. The second extension is queries. Given a feed, I would like to find the most interesting entry in this feed, and feeds can be very long. There can be millions of entries, as in Google Base, and you want just one entry. There were also some concurrency issues when updating a feed in Atom. For example, if two users are working on the same calendar entry at the same time, and they both want to set a different title, which title should be the one that's eventually used? Should it be the first one? Should it be the second one? What if they come at the same time? So concurrency, we added a layer of concurrency handling to solve this issue. We also added authentication. You don't want all your data to be publicly available on the web, just some of it. You don't want everyone to update your data. So we try and offer a solution for that. Another one which is not listed here is batch, which makes it possible to execute a certain number of operations at one time. GData is based on an early draft of the Atom publishing protocol. It has since been released in the form of RFC 5023, and GData doesn't implement what this RFC says. This is a situation the GData team doesn't like, and we want to make GData conform to this specification. So expect changes in the future. The core concepts of GData, you got two main data types, a feed and an entry. A feed is a collection of entries. A feed is what you usually query using RSS or an RSS reader. You got several entries in the feed. Using Atom Publishing Protocol, you can also query just one entry if you know exactly its URI. We recently added also, and it's also in the specification, a media data type. That is, you can post, you can delete data, any data such as videos, photos, documents. To this data, GData add 4 operations. You can create a new entry by posting something on a feed. It could be an XML entry, or it could be a media, like a photo. You can retrieve data. You can retrieve XML, the XML description of an entry, or you can also retrieve the media data. You can, as part of the retrieval is query. You can retrieve exactly what you want and how many you want. Update, if you want to change an XML entry, you can do it. Delete, if you want to delete an entry given its URI. So the first extension I talked about that Google added to the Atom Publishing Protocol is the data model. Here's what a fictional calendar entry can look like. It's a lot of information, but if we look first, we can see the standard Atom tags. An entry is defined as in Atom, an ID. The ID is very important for GData. It identifies the entry and makes it possible to retrieve it afterwards. Usually, if you do a get on this ID, you get the entry itself. The published and updated dates, of course, the title and content, and the author. That's all there is, and that's not enough to specify a calendar entry. So Google added a new tags in a new namespace. And to define this kind of entry, Google also defined a category, which is called kind, which is the first element in red on this page. So if you look at this category, you see that we've got an entry of the kind event. Entries of the kind events have tags in the GD namespace, like when, where, event status, and visibility. This is just an example. Other feeds will contain other kind of entries. For example, a Picasa entry will contain a media tag that will contain thumbnails, a link to the photo itself. This all depends on really what the entry is. Now, if we go back to the original XML, and this is what you get when you do a get on the URL you see in the ID, http mycalexample.com, and so on. This is exactly what you get. It's an example, it's shortened, but it's already a lot of information. And if you use a real-life example, you will see even more information. Sometimes the content is even HTML, so that's a lot. That's a lot to process. That's why it's very useful to group the tags you're interested in, first as atom, second as extension, and really concentrate on what you're interested in. Forget everything else. Don't expect an XML schema out of it. This is not SOAP. Atom is supposed to be a bit more dynamic, so really look for the tags you're interested in, focus on them, and forget everything else. To solve this problem, because it's a very common problem, several GData properties introduce the concept of projection. We haven't made a lot of it. It's documented in different properties, but it's, I think, a very useful concept, because sometimes you're only interested in the atom part of the answer, and why should you have to parse everything? So you can say with a projection, give me only the atom part of the entry, because I'm going to display that in an RSS reader, and I'm never going to care about GD1. This is often what is called the base projection. Similarly, you might not be really interested in the atom, especially not in HTML content. So you can say with a projection, give me only the API part of the entry, that is, give me the GD tags or any other tags depending on the property. Projections are very well hidden in the documentation. That's why I mention it here, because many people simply ignore it. Yet it's a very useful tool to work effectively with GData. Again, for operation, query, insert, update, and delete. I'm going to go through all operations and show you the XML code of it and comment on it. This was supposed to be a workshop. It's not going to be because of network issues. So I'm really going to go into details and try and highlight what you should care about as programmers. For querying a feed, this is a get operation, and listed here are standard query capabilities that most GData feeds support. Most GData feed will support more than that, depending on the type of the entry. For example, for a photo, you might be interested in the size of the photo. This is not here because it's specific to photo. But in most cases, you're interested in a full text query, which is the first entry here. Full text query, that is, if you type something on www.google.com, you get whatever Google thinks is relevant. It's the same idea here with the Q parameter. Second thing they could be looking for would be tags. We're tagging everything now. We're tagging photos. We're tagging videos. So it's a very powerful way of finding the information you're looking for. So we define a way of querying for categories. This is the // work play that you see at the end of the URL. It's rather more powerful than it looks like here, because you can say, give me the entries that are tag worked or play. but not Sunday. It's also very often it's also very often forgotten. That's why I mention it here. Another way of querying for entry is metadata. Ideally, if you have a field in an entry, it would be nice if you had a corresponding parameter to query on it. For example, for the updated field, it's nice if you can say give me everything that's been updated after this specific date or published after this specific date. Some fields support it. Something that all fields support is specifying the output format. The really interesting output format is JSON because it makes it easy to parse an entry using JavaScript. The data will be the same, but it won't be XML. It will be in a format that JavaScript understands more easily. Another output format that can be interesting at times is RSS. So instead of getting your data in XML atom, you get the data in XML RSS. But again, it's the same data. Now here's an example of a GET to begin with. This is what you usually do. You type in the URL into your browser, add a Q parameter, because it's very powerful. That is a full text search. And you get an answer. In this case, there was only one answer, only one Bennett in the feed. So the feed contains only one entry. More interesting, a post operation. Now, you would like to add a new entry to a feed. Now, supposing you've gone through authentication and are allowed to add a new entry to this feed, here's how you would do it. You would get the URL of the feed and post an atom entry to it. This atom entry has to be formatted in just the right way for the feed. And the feed specifies what tag should be there or what tag should not be there. Let's say you posted the entry that was on the previous slide and you got an answer. You were very lucky because this answer is 201 created, which means the entry was actually created. Next time you get the content of the feed, www.google.com/myfeed, you will see this entry as it appears here. Now, if you compare the entry that was posted and this entry, you'll notice that some tags have been added, the tags in red. They're the most interesting tag. The first one is the ID. The ID is assigned by Google. You cannot assign usually an ID when you post an entry. So this is how the entry will be known in the future. If you want to get this entry again, you need this ID. The second tag that is in red is the edit link. You will need this link to do other operations on this entry, and I'll get to it later. Two other tags are automatically generated by Google that you cannot modify, and the published and updated tag. Other feeds will probably have other tags that are either automatically generated or set by the user. Now, in the previous entry, I talked about the edit link. You should get this edit link to update an entry. If you see here, the put is called on myfeed/1/1, whereas the ID is myfeed/1. The 1 at the end is a version. And this is how we solve the concurrency issue I talked about before. Let's imagine two people want to update an entry. They want to update the same entry. Given this, if you use this URL, GData will know that you are updating version 1 on my feed. And if somebody else has already created version 2, that means there's something wrong. This is an optimistic locking mechanism, which makes it possible to detect concurrency issues and report them, but not prevent them. So if you do something on an old version, you will get not 200 OK, but 409. 200 OK in this example is when everything goes fine. this is not the kind of answer you see when you first start to post something or put something into a GData feed. Usually you see a 400 or a 404, which means there's something wrong. Error handling is a tricky part of working with GData. Everything is based on XML error code. So you should really know your XML error codes if you want to work effectively. That is, 200 is okay. 300 redirect should follow redirects. Sometimes they happen when you don't expect them. 400, there's something wrong in your query. 500, there's something wrong with Google, and don't think it never happens. It does happen. And in this case, you should be prepared to either retry or tell your user that something went wrong. So to come back to this example, the entry was updated successfully. And in red, you will see that the edit link has been changed. It now ends with 2, which means it's version 2. And the updated tag has been updated automatically. Now, the tag in blue is the tag that was actually changed by the user. So the operation actually worked. Last operation, and the easiest one of all, is delete. You give the ID. It says 200 OK if it's been deleted, or any other error code if, for example, the entry doesn't exist, or there's some concurrency issue and somebody created version 3, and you're trying to delete version 2. In the previous example, I just supposed you had the right to post something to a feed or to put something to a feed. This is not a given. This is actually a hard step to make. Authentication is hard, and it's required for every modification usually, because you don't want anyone to change your data. You want only yourself or some person you trust to change your data. The first authentication system that was added by Google is called client login. It's meant to be used by desktop applications. It goes like this. You ask a user for a username and password, send this username and password over HTTPS to Google, and Google comes back with a token that you can include in your requests. That means that the password never goes in clear over the wire, and if somebody is looking, they can't get your password. They can just get your token, and the token is only valid for a limited time, so it's not that bad. Now, it's not an authentication scheme that is appropriate for websites. Let's say websites communicate with Google, and they want to add new photos for you, but to do that, they need your password. And you're supposed to give your password, the password you use for Gmail, the password you use for everything, to this website you might not trust very much. So we came up with a different answer for that. This is called Authsub in the documentation. It's a little bit more complicated because now the browser must redirect the user to Google, where the user inputs the password over HTTPS again. Then Google sends back a token to the web application, which can now act as this user. In this example, the web application connects to the calendar data API. When the user gives authorization to the application, the authorization was only for calendar API. And it doesn't mean that the web application can connect to Gmail. Otherwise, you could only give access to everything or nothing. You can at least this way give access to one Google property. Those are the two authentication protocols that are supported by all GData feeds. More are in the work to solve problems like JavaScript authentication or syndication. So this is a list, a current list, I hope, of all the GData API. That's already many APIs, and it's hard to keep track of them. The first one on the list, Google Apps API. This is a way of managing users and data for application for your domain. Second one, Google-based API. This is a way of storing arbitrary structured information into Google and querying it. Blogger data API for your blog, calendar API, access your calendar, code search data API. If you're looking for code examples, Picasa web album for photos, spreadsheets for updating, accessing spreadsheets, document lists for other Office documents, including spreadsheets, YouTube data API for videos, and more coming. So back to the vision of GData. The vision is really to make it possible to do all kind of mashups, to put things together that usually don't belong, like in the timesheet with Google Office tools. It puts together a spreadsheet with calendar, so it gets data from a spreadsheet, put it in a calendar. This is simple but interesting. We could go further and integrate any kind of GData APIs, including non-GData APIs also. Like you could put something that gets photos from Flickr and put it in a calendar, just as well as you could put something coming from Picasa and put it in a calendar. This is one of the really interesting parts of APIs in general, that they make it possible to put everything together. One very interesting application is Yahoo Pipes, because, well, it's not been made by Google, and it makes it possible for several APIs to collaborate. In general, we've been trying to reuse as much standard elements as possible. This is not really a Google-centric protocol. GData is really meant to be a generic protocol, and we would like, in the future, GData to be used by to have other implementation, non-Google implementations. But for now, the goal is really for people to be able to use these feeds as easily as possible. So Google created a few libraries for Java, .NET, PHP, Python, Objective-C, and JSON. Those libraries are very close to the XML. That is, in Java, for example, for each tag, you will see a getter and a setter. It makes it easy to use these client libraries if you know the protocol. So the protocol will be the first step when you're trying to use a GData API. But it doesn't make it really easy in all cases. So one cool thing that's happening is that people are writing applications on top of or to replace those client libraries. For example, a new calendar library has been written to make it really easy to work with calendars, whereas the Google one was really close to Atom and everything. The third-party one shields you from everything that Atom might be that could be a bit too complicated or ugly that you don't want to deal with. Other contributed client libraries, third-party client libraries, Ruby, in Perl, and Lisp, and other languages. We're really looking forward to have as many client libraries as possible. If you want to connect to GData feeds, first thing you should do is go to the documentation and read the documentation. The really interesting part in this documentation very often is the URL. First thing you need to know about feed is the URL, and some explanation about what an entry contains. We got knowledge base to help you with common problems, and a very important resource, Google Data API groups. Each API has its own group where you can post questions and hopefully get answers. There are people who monitor those groups and try and answer every question as much as possible. There's a Google Groups wiki, which makes it possible to put as much information as you would like on these APIs. At the end of the slide is the URL you should go to. Okay, so I've got some connectivity issues, and I can't really connect to the network. I wanted to show you how to update entries, but all I can show you here is a real-life example. The other example were really made up. This one really is what you get if you query Google Base. And as I said before, it's a lot of information. So you need to choose what you really want, what you're really interested in. The namespace really helps. That's what I always look for. So the first one of the most interesting family of tags here is definitely those tags, OpenSearch tags. OpenSearch is has been defined by Amazon. It's used in all GData feeds to define how many entries you have in a feed and how many entries have actually been returned in the current feed. Because it's not possible to return as many entries as this feed has. So we have to split it into pages. And in this case, the default page size was 25. Here's an entry, example of a real-life entry. Unless you're writing an RSS feed, you're probably mostly interested in the tags that are specific to GData. And you might only be interested in one or two of these tags, depending on your application. So you should really, in the beginning, find out exactly what you're interested in. The tags have usually a name that is as explicit as possible, but sometimes it doesn't work for you. So it's best to have a look at the documentation, try and understand everything that can be put into such entries. So unfortunately, I can't go any further and give you any demo and workshops. So maybe we can switch to the questions.